Okay guys, so what we'll get into now for this part of chapter 1F is drawing your actual lines. Okay, so understanding how to draw your equation lines. Now, there are three ways to do this. And the first way we're going to look into is the gradient and y-intercept method. The other methods are going to be intercept method. And the third one will be, well, just sketching these special lines. But those are the three main ones that we're going to work with for today. So before we start though, I did mention before this formula, which is very important. The good old y equals mx plus c. This formula is going to be very important, okay, because it actually tells you two important pieces of information that shows you how to draw the line. Okay, and in this formula, remember that the m represents the gradient, and also remember the gradient is also considered, or you can see it as rise over run. Okay, you'll see it as rise over run, or you'll see it as slope as well. And c, in this case, represents your y-intercept. Okay, so this formula is very important. Okay, so please make sure you understand how it works. Y is always the variable that's generally by itself. Okay, so it's isolated. Y is generally on the left, and then the rest of the formula has mx plus c. So generally, if you are asked to find an equation, it has to be in this form. Okay, but for now, what you need to understand is m represents the gradient, which is also rise over run, and the intercept represents where it hits the y-axis. Okay, and it's generally a number that's by itself. Okay, so what we're going to try and do here is using the first method, which is the y-intercept and gradient method, figure out what the y-intercept and the gradient is for these questions, and then sketch the graph for them. Alright, so let's look at our first equation there. Okay, y equals 2x take away 1. Like I said in that previous formula there, y equals mx plus c. M represents the gradient and the c represents the y-intercept. So in this formula, I can see that my gradient, let's start with that, is 2. So the gradient is 2. However, now you might be thinking, okay, well, what's that got to do with the rise over run? So here's a trick. Whenever you see a gradient that's a whole number, put it over 1. Okay, because this tells you your rise over your run. Okay, your rise over your run. So there's my gradient, 2 over 1. And my y-intercept, okay, if you look at the formula, is -1 right there. I might use a different color for that so we can see it. So the y-intercept right here, okay, is -1. So that means on my y-axis, okay, the line is going to hit -1. Now to actually draw this, so we have the 2 bits of information now that will actually help us. To actually draw this, I'm going to bring in my Cartesian plane here, right, to draw it in there. Now most of your Cartesian planes will look something like this. Okay, now, you've probably seen a Cartesian plane before, and I think most of you will understand how it works. But I did mention before, so you just watch the previous, the earlier video or the earlier section to understand how this works. But when you get a question like this where it's asking you to draw the line using the y-intercept and gradient method, this is how I would suggest you do it. Start off with the y-intercept. So start at that point. And remember as well, you only need 2 points in order to draw a line. Okay, so I've already got 1 point, my y-intercept, which is -1. So let's start there. So therefore, on my Cartesian plane, start at -1. So my y-intercept is right here, -1. Okay. Now the next part is using the gradient to figure out where the next point is. So with your gradient, okay, I can see that it's rise over run. Now the reason why I made you guys, or I mentioned that with your gradient, if it's a whole number, put it over 1. Okay, because that'll tell you your rise over run, which tells you the number of units you need to move depending on what the gradient is. So if it's rise over run, 2 over 1. Okay. Also, another thing to remember is your gradient is a positive line. Okay, it's a positive gradient. Therefore, your rise needs to go upwards. So you need to go upwards with this line, not downwards. If this was a negative gradient, you'd be going downwards when you do this. So in this case, the rise over run is 2 over 1. So the rise is 2. So starting from that y-intercept, the rise, you need to rise 2 spots. So 1, 2. Okay, so you're rising 2. If it's positive, you go upwards. If it's negative, you go downwards. And the run, in this case, is 1. 2 over 1. Rise over run. Remember that. Rise over the run. So the run is 1. Generally, I always tell my students with the run, just run to the right. So the run is just 1. So there's your 2 points right there. The y-intercept of -1. Okay, -1, and the rise over run that I just did. So I rose, so the gradient, I rose 2 spots, and then I go to the right 1 spot. So there's my 2 points, my graph, and then from there you just join them to draw your line. Okay, let's see if I can do this. So your line will look something like that. I would suggest using a ruler to do this, as it makes your life a lot easier. Okay, but there's your graph. Okay, and generally you'd want to extend your graph all the way through, to the end of the Cartesian plane. But the main thing there is start off with your y-intercept. Okay, and then use your gradient to figure out where the next point will be. So in that case, it was rise 2, go and run 1. Okay, and if it's a positive gradient, you have to go upwards. If that was a -2 instead of a +2, then I would be going downwards. Okay, but in this case, it's upwards. And then I would run 1. So you always run to the right for run. Okay, let's try the next one. So find the gradient and the y-intercept for this. Now, you look at this formula and you might be thinking it's not actually in the y equals mx plus c form. And you are correct, it's not. So that means we actually need to rearrange this formula so it looks like this. Y equals mx plus c, where you have the gradient and you have the y-intercept, okay, on this side. All right, let's do that. So let's rearrange my formula so it looks like that. So the formula at the moment is 2x plus 3y equals c. No, 3, sorry. And what you want to do is you want to try and isolate y, make y by itself. Now, this is where, again, all the algebra stuff that we learned in previous lessons comes and helps you. So if you want to isolate y and make it by itself, what do you need to move? Well, you need to move the 2x and that 3 to the other side. So let's start by moving my 2x. Okay, so if I move this positive 2x to the other side and I put it here, it now becomes -2x. Okay, -2x. So what you're left with is 3y equals 3 minus the 2x. And the next thing to do is this 3 needs to get moved to the other side. Okay, this is a 3 times, so when I move it to the other side, it becomes divided by 3. So it's all of this expression divided by 3. So what you're left with is this. Y equals 3 minus 2x over 3. Now, if you, again, watch back to the previous videos, you look at this and think, okay, now what do I do? Do I try to simplify something or do I try to cancel things out? Well, you can't. Okay, you actually can't. But what you can do is you can actually split this thing up into 2 separate terms. So it should look like this. Y equals 3 over 3 minus 2x over 3. Okay, because what this is saying is all of this divided by 3. So if you just split it up, it actually looks like this. All right, and now if you have a look, I can just simplify this. 3 over 3 becomes 1, and -2 over 3x stays as -2 over 3x. Now the interesting thing here is now it's in the form of y equals mx plus c. except this time it's just swapped around a little bit. Remember the form was y equals mx plus c up here, in black, y equals mx plus c, except this time it's just a little bit backwards, but it's still the same. Okay, so don't fret, it just looks like this now, y equals c, okay, minus mx. Just looks like that. And I put minus there, or actually I could put plus, but I'll put minus there for now, because I can see that the gradient is a negative. So when I do my gradient and my y-intercept here, my gradient, okay, remember my gradient is always coupled with the x. It's always next to the x. Okay, so in this case, my gradient is right here, negative 2 over 3. So this is saying the rise is 2, the run is 3. Okay, there's my gradient. Okay, what about my y-intercept? Let's use another color. All right, y-intercept. Okay, you guys can probably already assume that my y-intercept is right here. Okay, it's 1. So my gradient is negative 2 over 3, and my y-intercept is 1. So on my graph, my y-intercept was just the number. Let's just clarify. Yep, the number 1. So let's start with that. I'm going to start at 1. Okay, there's my y-intercept. And according to this, my gradient is negative 2 over 3. So my rise is 2, and my run is 3. And remember what I said, if it's a negative gradient, for your rise, you have to go downwards. If it's a positive gradient, you go upwards. But in this case, it's negative 2. So starting from the y-intercept, I'm going to go down 2 spots. Okay, so because my gradient is negative, and the run, okay, was 3. So negative 2 over 3. So always run to the right. So the run was 3. So 1, 2, 3. So there is my other point. So there are my 2 points to draw my line. Okay, and then I just draw a line there. This is not going to look good, but again, use a ruler to do this, please. Okay. And there is the line for that rule. Okay, it does require a bit of work, but again, once you get used to it, guys, it's not that hard. Okay, let's go into the next method for drawing your lines. Okay, let's go to the next method for finding or drawing your lines. And this method is now looking into finding the x and the y-intercept. So the x and the y-intercept method. Okay. Now for this method, there's not really too much rearranging involved, although you might need to if you need to figure out, again, what x and y intercepts are. But when I say rearranging, I mean you don't actually need to rearrange it to make it look like this equation. Okay? You just need to rearrange it so you can figure out what x and what y is. Okay? Because that'll give you the intercept. So in this case, y equals 2x minus 8. Let me just rewrite the formula here. Y equals 2x minus 8. So what you want to do is, if you're trying to find specific intercepts, you need to change some of these numbers, or some of these variables, sorry, into 0. So if I want to find the y-intercept, okay, I have to change x to 0. So in that case, if I change x to 0, just write that here actually, so if this is for the y-intercept, change x to 0. So just remember that. For the y-intercept, change x to 0. And you can probably assume what's the next one. But let's do this. So change x to 0 in this formula. So y equals 2 times x, which will now be 0. Take away 8. And then we go y equals 2 times 0. Well, 2 times 0 is nothing. So you're left with negative 8. So your y-intercept is 8. Easy. Now for the x-intercept, it's slightly different. Okay, but similar principle. Okay, for the x-intercept, change y to 0. Whoops. Okay, so for the x-intercept, you want to change y. Change y to 0. Okay, so for the x-intercept, you want to change the y variable to 0. So in your formula of y equals 2x minus 8. Change y to 0. So it's going to be 0 equals 2x minus 8. Now you're left with this. But what you want to do is try and isolate the x. So make x by itself to figure out what the x-intercept is going to be. Now, because I like my x's on the left-hand side, I'm just going to rearrange this formula. And this doesn't change anything. Okay, I'm just going to rearrange it to put x on this side with the 8 as well, and then put the 0 on the other side. They've just basically swapped spots. Doing this doesn't actually change the formula. Okay, it just sort of reverses it, so it's easier to work with. For me personally, I prefer it to do this way, because now I can make x the thing that I'm looking for. So if I want to make x by itself, I have to move this 2 and this negative 8. Okay, so I'm going to first move this negative 8. When I move it here, it's a minus 8, so now it becomes plus 8. So you're left with 2x equals 8, and then this is a times 2, so when I move it here, it becomes divided by 2, so x equals 4. So your x-intercept is 4. Okay, so that means in my formula here, y-intercept equals negative 8, and x-intercept equals 4. Okay, now in terms of the actual coordinates, okay, if you look back again to the previous section of this video, or it might be the previous part, I'm not sure if I'll split it up, but the coordinates for these, okay, so for the y-intercept, x has to be 0, and the y-intercept must be 8, okay, and then for the coordinates of the x-intercept, x has the actual intercept, but y is instead 0. See how they're reversed. Okay, so for the y-intercept, x is 0. For the x-intercept, y is 0. And that relates back to, again, substituting the zeros to figure out what the intercept is. So if you want to find y-intercept, change x to 0. If you want to find the x-intercept, change the x to 0. Okay, so change this guy to 0. Oh, sorry, change the y to 0. My bad. Okay, so if you're going to find the x-intercept, change y to 0. Okay, so now all I've got to do is just put those 2 points in my graph and then join the dots. Okay, so my y-intercept is a negative 0, negative 8. So 0, negative 8 would be over here. Okay, and my y-intercept, my x-intercept is 4, 0. So 4, 0 would be here. 4, 0. So it's going 4, and I'm not going up or down any points. 4, 0. So there is my 2 points, and then you just join the dots horribly, but again, use a ruler for this to make sure your line is actually straight. We'll do that again. Okay, use a ruler for this, please, people, especially when you do your CFATs. Your teachers are not going to like wonky lines. Use a ruler, please. Okay, next one. Same method, x and y-intercept method. Okay, so remember the principles. If you want to look for the y-intercept, change x to 0. If you want to look for your x-intercept, change y to 0. Okay, so in this case, I might look for my x-intercept first. All right, so x-intercept, actually, I'll use red for x-intercept, but my formula is, I'll just use negative 3x minus 2y equals 6. I was about to say, hey, 6. Okay, so I want to find my x-intercept, change y to 0. So negative 3x times negative 2, minus 2 times 0 equals 6. So when you solve this, negative 3x is done as it is. Negative 2 times 0, well, that cancels itself out because anything times 0 gives you nothing. So you're left with negative 3x equals 6. Now remember, you want to try and isolate x to figure out what x is for the intercept. So get rid of that negative 3 times, okay, and it becomes a negative 3 divide. So 6 divided by negative 3. So you're left with x equals 6 divided by negative 3 is negative 2. So there's my x-intercept. Let's do my y-intercept. Okay, so negative 3x minus 2y. Get into the habit of rewriting your formula. Okay, it's actually a good thing to have. So for the y-intercept, okay, I'm going to now change x to 0. So this will be negative 3 times 0 minus 2y equals 6. So negative 3 times 0, again, cancels itself out. Anything times 0 is 0, and you're left with negative 2y equals 6. Okay, I want to isolate the y to figure out what the intercept is. So get rid of this, you got divide by, multiply by negative 2, and it becomes divide by negative 2. So that means the y-intercept is 6 divided by negative 2, which is negative 3. So nice and easy. On my graph, x-intercept is negative 2. So let's start with that. Negative 2 on the x-axis is right here. And then negative 3 on the y-axis for my y-intercept. Okay, so that would be here. And then from there, join the dots, and you'll have drawn your line. Oops. You'll have drawn your line for that rule. And generally, that's monkey. You want to make sure, okay, that you try to draw your line maybe towards the whole Cartesian plane. Okay, just a good habit to have. And also, that tends to be a good idea to write the rule in your graph, but that'll relate more into later subjects. Okay, so that's the x and y intercept method. Okay, guys, let's move on to the next part of drawing these linear equations. And the third one was just sketching special lines. And I did mention a few times how to do these before, but we'll just go through these ones here. So the first one there is a y equals 2. So what that's saying is there's a line, okay, that goes, or the line crosses through on the y-axis, the value of 2. Okay, and we can see that this also doesn't have a gradient. Okay, so when you see a y equals sort of formula and you're asked to draw it, it's just going to be a horizontal line like that with no gradient. Excuse the non-straight line, but a horizontal line just like that. So in this case, okay, y equals 2 would be y equals positive 2. So that means over the number 2 right here, we're going to draw a line that goes through it. So that is y equals 2. Okay, if it was y equals negative 3, negative 4, or whatever number, again, y would just mean it's a value, the line will just be going horizontally through the y-axis. Okay, and you can probably guess for x equals negative 3, it's a line that goes vertical, like that. But this time through the x-axis. So it's x equals negative 3, so that means we look for negative 3 on the x-axis, and it's on this line here. Okay, negative 3 falls in there. Okay, now this one gets a little bit trickier, but if you understand how to do the gradient method, or the y-intercept and gradient method, this actually isn't that hard. So if you look at this formula, I can see that there is no y-intercept. Okay, and what that means is the actual y-intercept in this case is right on 0. Okay, right on 0. Now the next part is drawing the gradient, or using the gradient to figure out what is where the next dot is going to be. So the gradient here is going to be negative 1 over 2. Rise over run is 1 over 2. It's a negative, so that means because it's if it's a negative, you have to go downwards for the rise, and then you go 2 to the right. So if we start at the y-intercept, so if it's a negative gradient, we go down, and then we go 2 spots to the right. Okay, so it's rise over run, negative 1 over 2. And then you just draw your line from there. Hopefully I can draw this one straight. Oh. There. And there. Okay, so there's my line for that formula. So just a couple things to make note with some of these questions. For y equals 2, this would be considered as a 0 gradient. So the line is just horizontal like that. 0 gradient. For x equals, so that for these kinds of equations, this gradient would be considered as undefined. Okay, and this one obviously has a gradient of negative 1 over 2. Okay, so that's how we draw these special lines.